All right, so this lesson's on adding, subtracting, and multiplying polynomials. So a polynomial function is a function where the exponents are whole numbers. Okay, so the exponents are whole numbers, which has to mean that they're non-negative. And the coefficients are real numbers. So coefficients are real numbers, which is not imaginary. There are standard forms for each of your polynomial functions, and there's a name, a degree, and a type. So if the degree, which is the highest exponent, is 0, that would be like the line y equals 2. There is no exponent there, it's 0. Then that would be a constant function. And there's examples right here, so I don't have to give my example of y equals 2. F of x equals 8, that is a constant function. If the highest degree is 1, so if you look right here, the highest exponent is 1, that's a linear function. The highest degree is 2, that's a quadratic function. So if you look right here, that's a quadratic. This is a cubic function. This is quartic. I don't know if you don't have to know after that. Maybe quintic is not, maybe I know fifth is quintic, but anything after that you can say 6th degree polynomial, 7th degree polynomial. Okay, so this example says decide whether the function is a polynomial. If it is, state the degree, the type, and the leading coefficient. All right, so to see if it is, we need to look at each of the exponents and make sure they're whole numbers. 3 is a whole number, 2 is a whole number, this is 1, which is a whole number, this is x to the 0 power, and that's a whole number. So exponents are fine. Now we're going to look at the coefficients. This is a -1, a √2, a -1, and a -9, which are all non-imaginary numbers. Imaginary numbers would have I in them. So this is a polynomial, yes. The other thing it asks us to is state the degree, type, and leading coefficient. So degree, type, leading coefficient. All right, so let's start with the leading coefficient. The leading coefficient is the coefficient on your first term as long as it's in standard form. So if you look, this is in standard form because the highest exponent is first. The leading coefficient would be the number in front of that, so it's -1. The degree is the highest exponent, so that's 3. And then the type would be the name that it was listed above. So this is a cubic function. All right, let's look at number 2 here. So we have to look first at our exponents. We have a 2. And if you look here, this has an x in the denominator. This is the same thing right here, is 3x to the -1st power. So this has a negative exponent. So this is not a polynomial function. So we don't have to state the degree, type, and leading coefficient because it's not even a polynomial function. Last one right here, if we look at our exponents, 3, 2, and 0, so that's good. Now we look at our coefficients. 5i is imaginary, so that's not good. So this is not a polynomial function. No. All right. So it looks like the first thing that's going to happen here is adding and subtracting polynomials. So it says, when adding or subtracting, add or subtract like terms. Perform the indicated operation, write answers in standard form. All right, so first thing I like to look to see what's happening. This is addition. So if it's addition, all I have to do is combine like terms. And you want to write it in standard form like it says. So we want to start with the highest exponent. So we look here, we have 3x to the 5th, and I look for any more x to the 5th, so I don't have them. So I'm just going to write down 3x to the 5th. Now I'll move on to x to the 4ths. I have a positive 2x to the 4th here, so plus 2x to the 4th. No more x to the 4ths. I have a 2x cubed and a -6x cubed, which is -4x cubed. Now I'll look for any squares. There aren't any. Now I'll look for any linear terms, which is a first power. There's a first power term, and there's a first power term. So -x and 3x is 2x. And then we'll go to the constants. The constants, 7 and -7, which is 0. So I'm not going to write down plus 0. And there is my polynomial in standard form. All right, next one, I look and I see that it's subtraction. When it's subtraction, I can't just automatically combine like terms because I have to subtract this, I have to subtract this, and I have to subtract this. So I have to distribute the negative. So that's what I like to start by doing. I like to say, all right, I'm going to, I don't know what just happened there. I'm going to change this to addition, and then I'm going to distribute the negative. So this would become a plus, this would become a minus, and this would become a plus. Now it's just like the last problem. So I'm going to go through and combine like terms. Highest degree is a third power, so this is going to be a cubic function. This is a third power, and this is a third power. Negative 6x cubed and 9x cubed is 3x cubed. Then I'll look for any squares. I have a 5x squared, and that's it. So plus 5x squared. Now I'll look for any linear terms. That's the first power. So I have a 12x and a negative 5x, which is a positive 7x. And last but not least, I'll look for any constants. Negative 1 and positive 19 is positive 18. So there's my polynomial function. So the only thing you have to remember here is adding is just combining like terms, and subtracting, you can't just immediately combine like terms. You have to distribute the negative to the second polynomial, and then you can combine like terms. All right, next looks like we're going to be multiplying polynomials. So it says when multiplying, distribute and use properties of exponents. So this is really important here. Make sure you're using properties of exponents, meaning when I say what's 4 squared, that means 4 times 4. So remember that when we get to anything with an exponent. It means take that and multiply it by itself. All right, so perform the calculator operations, just write your answer in standard form. Okay, so I have to multiply these 3 polynomials. If this wasn't here, I think everyone would say, no big deal, you just FOIL it. And that's what we're going to do. We are going to first start off by multiplying these 2 right here. Okay? So we're going to use the distributive property, which some people call FOIL. But I'm just going to pretend this is not here for a second. Okay? And then I'll worry about it in the end. All right, so let's multiply the first 2 binomials. I'm going to distribute the x to this and to this, okay? So some people call this distributing the first term. That's what the f stands for. X times x is x squared. Distribute the x here. This is called outer. X times 3 is 3x. Now I have to distribute this negative 2. Negative 2 times x is negative 2x. That's also called inner. Negative 2 times 3 is negative 6. This is also called last. So that's why it could be called FOIL. Multiply the first terms, the outer terms, the inner terms, and the last term. Next, what we want to do is we want to combine like terms here. These 2 are like terms, so we want to make it one term. So that's x squared plus x minus 6. Now we're not done because all that we did was we multiplied these 2. We forgot, we didn't forget, but we didn't do times x plus 4 yet. So now we have to start over and multiply these 2. So all that you're going to do is use the distributive property. You're going to start by distributing the x squared. So I'm going to circle it so we can see what I'm distributing. I'm distributing the x squared to everything in the second binomial. X squared times x is x cubed. X squared times 4 is 4x. Now I have to distribute the x. So I do x times x, which is x squared. X times 4, which is 4x. And I realized I made a mistake right here. In the green, that is. I said x squared times 4 is 4x when it's 4x squared. Now, the reason I realized I made my mistake is because I was noticing a pattern. Like this is a 2 and this is a 1, so this had to be a 3 and a 2. So I realized by looking at it when I was doing it that I made a mistake. But I caught it, so it's fine. All right, now I'm going to distribute this negative 6. Negative 6 times x is negative 6x. And negative 6 times 4 is negative 24. Last thing you have to do is combine like terms. So highest exponent is a cube, so that's x cubed. Got that. So I have a 4x squared and an x squared, which is 5x squared. I have a 4x and a negative 6x, which is negative 2x, and then minus 24. All right. Next one here, I got to multiply these 2 trinomials. All that you're doing is using the distributive property. So I'm going to distribute the x squared. X squared times 3x squared is 3x to the 4th power. X squared times negative 4 is negative 4x cubed. X squared times negative 1 is negative x squared. All right, now I have to distribute the 2x. 2x times 3x squared is 6x cubed. Because there's an x to the first here and an x squared there. So there's x cubed. 2x times negative 4 is negative 8x squared. 2x times negative 1 is negative 2x. now I have to distribute that 3. So distribute this 3. 3 times 3x squared is 9x squared. 3 times negative 4x is negative 12x. 3 times negative 1 is negative 3. Now, before I combine like terms, I'm going to look for just my pattern again to see if I made a mistake. I have 4, 3, 2, 3, 2, 1, 2, 1, 0. Because the only place that I personally make mistakes is sometimes I'll get an exponent wrong because I'm working too quickly. And it looks like I did good there. All right, last but not least, I'm going to combine like terms. We'll start with the highest degree or highest exponent, which is a 4, so that's 3x to the 4th. All right, now look for cubes. I have a negative 4x cubed and a 6x cubed, which is 2x cubed. I have a negative x squared, a negative 8x squared, and a 9x squared, which is 0x squareds, so I don't have to write anything down. Those are gone, right? Then I have a negative 2x and a negative 12x, which is negative 14x, and then a minus 3. And there is my polynomial function in standard form. All right, last but not least is using this exponent here, which is x minus 3 cubed. So recall what I said before. When I said that I have 4 squared, that means that I'm multiplying 4 times 4, something times itself. 4 cubed is 4 times 4 times 4, something times itself 3 times. So what people will try to do, which is very wrong, is distribute this cube. You can't distribute an exponent. What this means is that you have to multiply this by itself 3 times. So you have x minus 3 times x minus 3 times x minus 3. Now this is just like the first one right here, where you multiply the first two, and then whatever you get, you multiply that by the third one. So let's go ahead and multiply the first two. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. This is going to be times x minus 3. I want to clean this up first before I start multiplying. Otherwise, I'm going to do work than I have to, more work than I have to. X squared minus 6x plus 9, because I combined these like terms, times x minus 3. All right, almost done here. We just have to distribute and combine like terms. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. Negative 6x times x is negative 6x squared. Negative 6x times negative 3 is positive 18x. Distribute the 9. 9 times x is 9x. 9 times negative 3 is negative 27. Last but not least, combine your like terms right in standard form. So I have an x cubed. I'll look for my x squareds. I have a negative 3x squared and a negative 6x squared, which is negative 9x squared. 18x squared and 9x squared, which is 27x. I'm sorry, I said squared, but they're just x's. And then minus 27. And there is my polynomial. Last thing that is said here is just some helpful patterns to remember. If you have to multiply, these are called conjugates here, where it's the same number, same number, same number, same number, opposites. The outer and inner term will cancel if it's, like x plus 2 times x minus 2. So a shortcut is just to square the first term, square the last term, and have subtraction in between them. This is just all the rest of this is just special patterns. What I would just remember is that if you have a plus b squared, you have to do a plus b times a plus b. And that way you'll get this pattern here. This you have to do a minus b times a minus b. You have to do a plus b times a plus b times a plus b. A minus b times a minus b times a minus b. It's saying that there's a special pattern here because what it's saying that if you notice, to go from this x minus 3 cubed to the answer, you could have this special pattern memorized here. It says to cube the first terms, that's x cubed, minus, and then you have to do 3 times a squared times b. So 3 times x squared times b, which is a negative 3, or just the 3, my bad, just times 3. So that's where this negative 9 comes from. I think it's too much work to memorize these patterns. I think it's just easier just to multiply those out. Okay? All right, that's it for these sets of notes. Go ahead and try the